Hey everybody, how you doing? Mr. Elliott here. Doing my first video lesson after a week-long vacation. I hope your vacation was awesome. Mine was pretty good. Anyway, what we're going to be doing today is we're going to be multiplying and dividing rational expressions. I'm going to show you quickly the 5 examples I'm going to be doing. I'm going to be doing this example right here. Next, I'll be doing this example. Third example I'll be doing is this one. And then the fourth example I will be doing is that one. So at the very least, make sure that you do these 4 examples and you get them into your notebook so you can get an awesome notebook grade. That would at least get you a 3. But anyway, let me work through these 4 examples. Multiplying fractions, nothing fancy. You just go numerator times numerator and denominator times denominator. But before you multiply, I strongly recommend doing any kind of simplifying you can. Like I noticed that 93 and 21 are both divisible by 3, making it 31 over 7n. 34 and 51, those are both divisible by 17, of course. I wouldn't expect you to know that one. But if you divided both of these by 17, you'd get 2 over 3. And then I noticed that these ends also nicely cancel out. So instead of multiplying complicated numbers or big numbers, we can multiply much smaller numbers. 31 times 2 is 62. And 7n times 3 is 21n. Then last thing you want to ask yourself is the answer, can I simplify the answer? And in this case, no. This one is fully simplified. So I simplified, then I multiplied, and then I tried to simplify again. Common theme with these problems. Alright, division problems. First of all, just like the other problem, the first thing I'd do is I'd simplify. 4n and n minus 6, they don't have anything in common, so that's going to stay as is, divided by this 2 here, this 8 here, and this 48 here, they're all divisible by 2, making it n over 4n minus 24. And you can only do this because of the subtractions. You have to divide from all 3 of these. Okay. Oh, and at the same time, this is factorable, so it could become 4n over n minus 6 divided by n over 4 times n minus 6. Now, what I learned in elementary school was when you divide fractions, not to divide the fractions, to multiply the fractions. But multiplying fractions is the same thing as dividing, or dividing fractions is the same thing as multiplying by its reciprocal. So instead of going 4n divided by n minus 6, divided by this stuff, we're going to go times. So dividing or multiplying, getting this mixed up. When you're looking at a division problem, dividing by a fraction is the same thing as multiplying by its reciprocal. So 4 times n minus 6 divided by n. Key step there. You could have done this on the very first step too. That frequently happens. Now when I multiply across, I notice that this n will cancel out with that n. This n minus 6 will cancel out with that n minus 6. Everything on the denominator is gone away, so I'm left with a 1. And up top I have 4 times 4, which is 16. 16 over 1, which would just simplify down to 16. Why is this called example 6? Because it's number 6 from your worksheet on your homework. 25 problems on the worksheet. It didn't seem necessary to have to do all 25 problems. Okay, number 13. Okay, so I need to simplify. I got a lot of simplifying here to do, and it's a division problem. I do want to change it to multiplication. So I'm going to do kind of multiple steps at the same time. This numerator 7a squared stays 7a squared. The denominator, I can factor this by pulling out common factors. What do these two things have in common? Well, they both are divisible by 7, and they both have an a squared. So I can factor out a 7a squared, and what would be left on the inside is a plus 8. And then times, so I'm changing the division to a multiply, meaning I have to reciprocate the second fraction, so that's going to become a 2, and the numerator is going to become the a squared plus 7a minus 8, but I can factor that. Let's see, this factors into a plus 8 and a minus 1, and I've fully simplified all the different parts of the fractions, and I changed the division to multiplication, and I reciprocated. So now I can cancel out stuff, common factors that you have on the numerator and denominator. For example, 7a squared is on both of them, a plus 8 is on both of them, and the only thing I'm left with is this a minus 1 and the 2. So a minus 1 over 2, and that's fully simplified. Alright, one more example for you today. It's a multiplication problem. Yay, so I don't have to change from division to multiply and reciprocate, but there is some simplifying to be done specifically over here. There's no simplifying to be done with this first one, so it just stays 45x squared over x minus 9. And then the second one, let's see, multiplies to negative 36, yet adds up to negative 5. That would be negative 9 and positive 4. And if you're not a good factorer, one thing to remember in these problems is that things are supposed to cancel out on the numerators and denominators. So when you see this x minus 9 here, there's a good bet that there's going to end up being an x minus 9 somewhere in the numerator. So just try it out. X minus 9 times what? For that to work out, it would have to be x plus 4. And then you can check with the outers and the inners to make sure it really works out. Denominator. What do these two things have in common? They both have a 3x squared in common. And if I factor out the 3x squared, what would be left on the inside is x plus 4. Alright, so we got a lot of canceling out here. X minus 9 cancels out with the x minus 9. X plus 4 cancels out with the x plus 4. The x squared cancels out with the x squared. And the only thing that's left up top and down below is 45 over 3. But that can be simplified. What can you divide out of 45 and 3? That would be 15. No, it would be 3. Both of them are divisible by 3. So you get 15 over 1, which is, of course, just equal to 15. So, in these problems, first step, simplify. Second step, cancel out. And multiply. And then sometimes after you've canceled out and multiplied, it'll need to be simplified again. Simplify again. So you want to start and end every problem with simplifying. This is actually a good example. I simplified up the numerator, stuff canceled out, but then when I combined it together, I got something that could also be simplified. So, alright, so those were 4 sample problems off of multiplying and dividing rational functions worksheet. So try out the other 21 problems on your own, and if you can do all those problems, you're going to do great on the daily quiz and on the normal quiz and on the test and all that wonderful stuff. So have yourselves a great day. I'm going to go upstairs and find a cookie. Bye-bye.